Dear audience, today I am going to discuss about the properties of real numbers. So, the addition properties of real numbers. The first addition properties of real numbers is known as the additive closure law. That means if a and b are real numbers, then their sum a plus b will be real number. This rule is known as the additive closure law of real number. Example. Here we consider 2 and 1 by 3 are real numbers. So their sum 2 and 2 plus 1 by 3 equals 7 by 3 is also a real number because the square of 7 by 3 is 49 by 9, which is the non-negative number. So we can say that the sum of any two real number is also a real number. Now I am going to discuss about the second addition rule of the real numbers, which is known as the additive associative law. When a, b, c are real numbers, then if we add c with the sum of a plus b, and if we add a with the sum of b plus c, then they will provide the same result. That means a plus b within the bracket plus c equals a plus within the bracket b plus c. For example, we consider 2 minus 3, 5 are real numbers. Then we add 5 with the sum of 2 and minus 3, we get 4. Again, adding 2 with the sum of minus 3 and 5, we get 4. So we can say that for any three real numbers, additive associative law hold. Now I am going to talk about the third addition rule of real numbers, and it is known as the existence of additive identity. That is, for all real number a, there exists a real number 0 such that a plus 0 equals 0 plus a equals a. That means 0 will disappear in the real number a. And here 0 is called the additive identity, which disappears itself in any real number when it is added with a real number. For an example, if minus 2 and 0 are real numbers, then adding 0 with minus 2 will find that minus 2, and again adding minus 2 with 0 we get minus 2. So from here we can find that 0 disappears in minus 2, and that is why 0 is called the additive identity of the real numbers. Fourth rule, existence of additive inverse. For all real number a, there exists a real number b such that a plus b equals b plus a equals 0. Here a and b are additive inverse to each other. For example, if we consider minus 3 by 2 is a real number, then there exists a real number 3 by 2. Now adding these two numbers, we'll find 0. Similarly, adding 3 by 2 with minus 3 by 2, we get 0. So we can say that minus 3 by 2 and 3 by 2 are the additive inverse to each other. A5, additive commutative law. If a and b are real numbers, then a plus b equals b plus a. That means if we exchange the place of the first and second real number, then the sum will remain unchanged. For an example, if we add minus 2.5 with 3.5, we'll find 1. Again, if we add minus 2.5 with 3.5, we will find 1. So the result remain unchanged. And we can say that minus 2.5 and 3.5 satisfy the additive commutative law. Now I am going to discuss about the multiplication rule of real numbers. So first multiplication rule is M1, which is known as the closure law. If A and B are real numbers, then their product AB is also real number. This rule is known as the multiplicative closure property of real numbers. For example, if minus 4 and 3 by 16 are two real numbers, then their product is minus 3 by 4 is also a real number because the square of it is the 9 by 16, which is non-negative number. So we can say that minus 4 and 3 by 16 are closed under multiplicative closure property of real numbers. M2, multiplicative associative law. That means if A, B, C are real numbers, then A, B into C equals A within bracket B plus C is known as the multiplicative associative law. Example, we consider 2 minus 3 and 5 are real numbers. Then we multiply the product of 2 and minus 3 by 5, we find minus 30. Again, we multiply the product of last two numbers minus 3 and 5 by the first number, we get minus 30. So we can say that the real numbers satisfy the multiplicative associative law. M3, existence of multiplicative identity. For real numbers A, there exists a real number 1 such that A times of 1 equals 1 times of A equals A. That means 1 disappears in A. And here 1 is called the multiplicative identity, which disappears itself in any real number when it is multiplied by the other real numbers. For an example, for all real numbers minus 3 by 2, there exists a real number 1 such that minus 3 by 2 into 1 equals 1. Equals 1 into minus 3 by 2 equals minus 3 by 2. That means here 1 disappears in minus 3 by 2. M4, existence of multiplicative inverse. For all real numbers A, there exists a real number B such that AB is equal to BA equals 1. Here A and B are the multiplicative inverse to each other. For example, if minus 3 by 2 is a real number, then there exists a real number minus 3 by 2 such that the product of minus 3 by 2 and minus 2 by 3 becomes 1, and again the product of minus 2 by 3 and minus 3 by 2 is also 1. So we can say that minus 3 by 2 and minus 2 by 3 are the multiplicative inverse to each other. Fifth multiplicative rule, that means multiplicative commutative law, is for all real number A and B, AB is equal to BA. Example, minus 3 by 2 and minus 2 are two real numbers. Then if we multiply minus 3 by 2 by minus 2 and 2 by minus 3 by 2, then the result is 3. So we can say that minus 3 by 2 and 2 satisfy the multiplicative commutative law. Now I am going to talk about the distributive actions for all real numbers ABC. The distributive law is A times of B plus C equals AB plus B A into C. Similarly, a plus b times of c is equal to a times c plus b times c are hold. Example, for all real numbers 2 minus 3 and 5, we find if we multiply the sum of minus 3 and 5 by 2, we'll find 4. Again, if we add, that means if we find the sum of the product of 2 and minus 3 and 2 and 5, we'll get 4. So we can say that the number 2 minus 3 and 5's distributive law hold, ordered law. So the first ordered law is the trichotomy law. If a, b are two real numbers, then any of the following is true. That means a may be greater than b, or a may be equal to b, or a may be less than b. For example, if we consider two real numbers minus 3 and minus 3, so we say that these two real numbers are equal. If we consider two real numbers minus 5 and minus 3, we'll find that minus 5 is smaller than minus 3. If we consider two real numbers minus 3 and minus 4, we'll find that minus 3 is greater than minus 4. Now I'm going to talk about the transitivity law. Transitivity law. If a, b, and c are real numbers, and a is greater than b and b is greater than c, then a will be greater than c. This rule is known as the transitivity law. For example, minus 3 is greater than minus 4 and minus 4 is greater than minus 6. So we can say that minus 3 is greater than minus 6. Third order rule, for all real numbers a, b, c, and if a is greater than b, then we can say that a plus c will be greater than b plus c. That means if we add any real numbers to the both side of an inequality, then the sign of the inequality won't be changed. For example, here an inequality is given, minus 3 is more than minus 6. If we add minus 2 to the both side of it, then we will find minus 5 and minus 8. And it is clear that minus 5 is greater than minus 8. That means the sign of the inequality won't be changed. Fourth order rule. For all real numbers a, b, and c is greater than 0 and a is more than b, then multiplying both sides of the inequality by the positive number c, we get ac is more than bc. That means if we multiply or divide the both sides of an inequality by the positive number, then the sign of the inequality won't be changed. That means greater than sign will remain greater than, and smaller than sign will remain smaller than. For an example, minus 3 is more than minus 6. It's the inequality. If we multiply both sides of this inequality by the positive number 2, then we'll find that minus 6 and minus 12. And it is clear that minus 6 is greater than minus 12. So in place of greater sign, we have to put the greater sign. That means the sign of the inequality remain unchanged. For all real numbers a, b, and c, and if c is negative, that means less than 0, and if we multiply the both sides of the inequality a is greater than b by the negative number c, then the sign of the inequality will be changed. That means here greater than sign will be the smaller than sign, less than sign. For example, here minus 3 is greater than minus 6, but if we multiply the both sides of this inequality by the minus 2, that means negative number, then we will find that it will be the 6 and it will be the 12, and it is clear that 6 is smaller than 12, so the greater than sign becomes smaller than sign. Now I am going to talk about the completeness actions. What is the completeness actions? Every non-empty set of real numbers which is bounded above has at least upper bound or supremum. Least upper bound, another name of the least upper bound is called the supremum. Okay, so here we have used some new terms: the set, bounded above, least upper bound or supremum. So first of all, I'm going to discuss about the set. Set means the collection of sets of real life or imaginary life. If we consider a set, if we consider a collection of numbers, the odd number less than 6 are the 1, 3, 5, and so it is the set, and we consider the name of the set is A, and it is clear that it is non-empty set because it has 3 elements, so we can say that it is non-empty subset, non-empty set of real numbers. But is it bounded above or bounded below? How do we understand? If there exists a real number, again I repeat it, if there exists a real number which are greater than or equal to each of the elements of the set, then we should say that the set is bounded above and the real numbers which are equal or greater than each of the elements of the set A will be known as the upper bounds. So here obviously we find some real numbers, for example 5, 5.0001, 5.0001, 5.001, etc. Those real numbers, each of those real numbers are equal or greater than each of the elements of the set A. So we can say that the set is bounded above and those real numbers are known as the upper bounds. But among those upper bounds, which elements is the smallest here? Obviously 5. These smallest upper bound or least upper bound is known as the supremum. So here the supremum is 5. So I write it here. Supremum is 5. 5 is the least upper bound, which is known as the supremum. So you have to keep it in your mind that every non-empty set of real numbers which is bounded above has at least upper bound, has a least upper bound or a supremum. Since the set A is bounded above, so we can say that it has upper bounds, and among the upper bounds we get 5 as a least upper bound, so the supremum of it is the 5. I am going to talk about the second completeness axioms. The second completeness axioms is the every non-empty set of real numbers which is bounded below has the greatest lower bound or infimum. We consider the same set here, and it is non-empty set, and we can consider some real numbers here which are equal or smaller than each of the elements of the given set. We consider some element here 1, 0.99, 0.98, 0.97. Each of those real numbers are equal or smaller than each of the elements of the given set A. So we can say that this set is bounded below, and the real numbers 1, 0.99, 0.98, 0.97 are known as the lower bounds. And among those lower bounds, the greatest lower bound is 1 here. So 1 is the infimum. So we can say that every non-empty set of real numbers which is bounded below has the greatest lower bound or infimum. Dear audience, I hope that you could understand the today's lessons, that means relating with the properties of real number. Again, I will come along with a new video tutorial. Till then, goodbye.